Here is how you find slope of a line. First, let me define slope as the change in y over the change in x. So the first thing that we need to do, which has already been done for us in this example, which is to find two coordinates that we can use. Okay, I'm going to start with this one here. Okay, they have given me two coordinates. Okay, and naturally we are going to move from left to right, which when I look at this is the furthest dot to the left. Okay, of these two coordinates, this one is further to the left. So make sure you count by whatever units the graph is using. In this case, the graph is not using any numbers, which means that each one of these is 1. And what I'm basically going to do is kind of count the lines that I'm crossing. This can be kind of a difficult thing to explain, so I'm going to show it to you. So here, what I'm going to do is count the units, and it says from the left dot, see if you need to go up or down first. So in this case, to get to this next one, I clearly need to go up. That means that I'm going to be using a positive number. So as you can see here, I'm right here. As I move up one line, that's 1, 2, 3. When I'm here, I am directly across from the other coordinate that I'm trying to get to. So I have gone as high as I need to go. So this will be a change in 3. Okay. And we always write slope as a fraction. As I said, it's change in y over change in x. So how much I go up or down, in this case up, was 3. That is my numerator, my change in y. Now, once I'm here, I need to do the same thing and just count. Make sure, again, to reference the amount of units that you're using. But in this case, it's 1. So we just need to count by 1. 1, 2. That will be your x value, which is at the bottom. And if need be, make sure you simplify, which I don't need to. 3 over 2 is all it is, and that is how you find your slope. Okay. I will point out one major flaw that I watch students do all the time, is when they're counting, if they were to go from here to the right, they will count but go like this. 1, 2, 3. So let me point out, you do not count until you actually move. So right now we would be at 0 because we have not moved. 1, 2. Let's look at another one real quick. So start with the unit to the left. Make sure that what we're counting by, which in this case again is 1. We're going to move from the left dot and see if we need to go up or down. Again, my other dot is above us, so I need to go up, and I'm simply going to count 1, 2, 3, 4, 5, 6, 7. 7 up, and 1, 2, 3 over. So it is 7 over 3. I'm going to move over to this one now. And this time, starting at the left, I need to move down. And anytime we move down, that is going to make our slope negative. So we are still going to count, but know that it's 1, 2, 3 down. So it is a negative 3 as my change in y. And I was here, 1, 2. And on this one, I'm going to go ahead and draw a line for you real quick, just so you can see what I was counting. I was counting the line that I've basically just drawn, that change. And if you want to pause the video and try and follow these steps and see if you can answer 5, do that now. Okay, hopefully when you work this problem out for yourself, you came up with 5 over 3, which also cannot be simplified. But just so that I could show you a couple things that would need to be simplified. If you got 2 over 1, 2 over 1 equals 2, because 2 divided by 1 is 2. A number like 2 over 4, we know 2 goes into both of these numbers and becomes 1/2. 1/2 cannot be simplified. So this is our final answer.